Well, glad to have everybody with us today, and today we're going to talk about the fundamentals of the Altronic 3 and the 5 and some troubleshooting, and then in the end we're going to go into the NG Altronic 5 and show you some of the differences between the systems. So I have quite a bit of material to cover here. We have almost 60 slides, and if at any time during the presentation somebody has a question on the slide that we're presenting, feel free to speak up. Again, just if your mic is muted, all you have to do is press your space bar and hold it while you speak, and then release it, and then it'll unmute your mic. Again, just ask any questions while we're on that slide. Okay, so the Altronic 3 and 5. The Altronic 5 fits the 1 to 6 cylinder engines. They look much alike the 3 and the 5. 2 to 16 cylinder engines on the Altronic 3, and originally, these are replacing magnetos. In the old days, the Altronic 3 was sort of revolutionary because nobody made a 16 cylinder magneto, so they were typically 2 8-cylinder mags on a V16 type engine. So that eliminated the duplication there. So again, they sort of crossover applications in the, where it's a 4 or 6 cylinder, but the Altronic 5 is less costly. So in many cases, that would be the choice, when somebody's looking at costs. They share mostly the same SAE mag drive mounting options. And these SAE mag drives were generated on the engines many, many years ago before we existed. And these were to drive the magnetos that preceded the Altronic variations. And the Altronic is a solid state capacitor discharge ignition, where the magnetos were magneto principle. It's a little bit different. A lot of advantages to the passive discharge systems, but there's a variation in the mag drives. SAE, the Society of Automotive Engineers, designate that these are all manufactured to the same specifications, so we fit on all the different variations that they've produced over the years. Just to look at the A, you've got a capped hole at the top of the A flange right here, and down here you've got a slot, and the whole design is so that when you put this on, you've got a bolt that goes through the slot, and then you've got a bolt that comes through the engine, and the engine drive has a slot on it. So when you loosen the bolt top and bottom, you're able to rotate this ignition to sync the timing into the exact timing position, because you can never put it on there and match it up perfectly, so you have to have some way to adjust it. For the old timers out there who ever worked with distributors on automobiles, the distributor always had a clamp on it, and you can rotate it. So in order to change the timing, you would loosen that clamp with your timing light. You'd move the distributor, and while you're watching the timing light, and sync the timing into right where you wanted it to be. So the different variations, the AO, the O has an O-ring groove in it. That's for Caterpillars. The D flange is a smaller pilot diameter, 3-inch pilot. The G flange is just basically 2 slots horizontal. So between the 3s and 5s, these are somewhat similar. And the difference between the 3 and the 5 is that the 3, these flanges are bolted on. There's 4 bolts, so that all the housings are somewhat similar, and all you have to do is bolt on the different flanges, where the Altronic 5s are machined in that fashion, so they are fixed when you purchase them. So the Altronic 5, 1 to 6 cylinders, gets rid of the magneto, breaker points, and impulse couplings. Breaker points, obviously, on the old magnetos, they wore. Timing would go off. You'd have breakdown in the operation of the ignition. So it would degrade over time, where the Altronic 5s and 3s with the solid state triggering, you're not going to have any change in that over time. Impulse couplings were something on the old magnetos on some engines that were slow cranking that would actually somewhat wind up and were spring loaded, so that as the engine would start to rotate, it would wind up and then spin more quickly to give it a little impulse to start the system. So those are all eliminated with the Altronic V. These are all CD ignitions. The alternator is contained within the unit and the distribution, so it's basically totally replaces a magneto, just like a magneto is self-contained. Extended spark plug life with the capacitive discharge, ignition performance. These things go on and they perform for years and years without any maintenance, where the magnetos had to be rebuilt every 6 months or year, depending on the operation. And ease of service, plug-in modules and removable back cover. Most people would replace the entire Altronic V if there were an issue with it, but you can just replace the back cover, and that replaces all the triggering and electronics. So it can be done that way. And all these are built in the same fashion, where depending on the harnesses and the coils and the spark plugs and leads, they're all built so that you can adapt them with those options to make them suitable for a hazardous area certification. So this view, if we just take a quick look at the back cover, the one thing that may not be shown in further slides is that there is a timing indicator here with a red mark on it, and there's a clockwise and a counterclockwise mark on this cover there. And that is what you're going to align when you're putting the ignition on the engine. So keep that in mind as we move on. So these are totally self-powered. When we saw, we'll see it in the next slide, the gears and everything that's internal to it. The magneto drive, these engines are built with various magneto drive ratios, which is the ratio to the engine crankshaft. And we accommodate all those magneto drive ratios to get the back cover at the right speed by the internal gears. And there's different gear ratios. And based on the number of cylinders, 2 cycles, there's different drive ratios. And most of the 2 cycles are like Ajax engines and such. Most of these are going on 4-cycle engines. And in the 4-cycle, the drive ratios available are typically 1 to 1, 1.5 to 1, and so forth. The mounting flange we saw in the previous slide, where you have the 3.25-inch pilot, and then we have the 3-inch pilot, the D flange. So all these have a standard designation for the different variations. The one that you see right here with the extended shaft, these are the ones with a W at the end. And the W, this has a typical coupling on it, but it's also got the extended shaft where a gear is mounted onto that. And that gear is supplied by the engine manufacturer, so we'll take a look at that in further slides. The other thing that's an option on the Altronic V is the T option. T is for timing, and that is a unit where in the part number it adds a T to the part number and gives you this connector on the back. And when the pickup coils are triggered, they're triggered on, and then when it passes by, it goes off after some number of degrees. And during that number of degrees of being triggered, you're able to delay the firing by running it through a box like this. And this box with the connections here can be enabled or disabled with some connections here, and an external switch that might turn on your propane or your backup fuel, so that when you do have a dual fuel or dual load, you can flip a switch, change fuel, change timing on the unit, and that timing is adjusted with the screw right here. So this is a potentiometer, so you can dial in the number of degrees of retard with the box, and then enable or disable the box with an external switch.
Tom, what about if a customer wanted to remove that box, or the box went bad? What could they do then?
Yeah, the box, there is a shorting plug, and when we show you the options, we'll bring that part number, and it's in the application list that if you do not use this box, when you look at the installation instructions for the box, you can just basically make a connection between two terminals here, which is the same thing as the shorting plug. So basically, when you use an external switch, you short the box out and don't allow the influence of the potentiometer. And then when you open the switch, you allow the influence of the potentiometer through the box. So you can do it either by knowing how to short the contacts on that timing box or use the shorting plug. But if you don't have a connection there through the shorting plug or through the box, the unit will not fire.
Thanks.
So the alternator section, as you see on the left, has a rotor and stator combination internally and a drive gear. And then the output of that stator has a connection that plugs into the back cover. When you plug it in and then put it together, you're going to have this drive gear driving the back cover, and underneath this, and it'll be shown better in further slides, how this arm below there triggers the pickup coils. But again, almost all the electronics are in the back cover, circuit board, pickups for all the triggering. So that's where the majority of the components lie. The only thing you have in the front housing is the shaft drive coupling and the rotor stator combination. Stators do fail at times, sometimes if these things get water in them, but usually they're good for a good long time. This is the pickup coil shown in red, as you see right here, just that ring around there. That's the A coil. So when that counterclockwise and clockwise mark is aligned, and when this gear is put on there, this is the bottom of that gear. And this arm right here is magnetized by the magnet, and every time it passes by, when it goes by the leading edge, it triggers on, and as it passes by and goes past it, it's going to turn off. So this pickup coil is on from this edge to this edge as that piece goes past it that's magnetized. So when you align the edge of this up on one side, the clockwise mark will be lined up. And when you line it up on this edge, the opposite one will be lined up. So each side of it is one side's a clockwise and the other side's a counterclockwise mark alignment. The other thing that you see in here is the circuit board. That's mounted internally. That's separate from the pickup coil assembly. And when we get into the NG, you'll notice that the NG system replaces this circuit board and the pickup coil assembly with one single circuit board and a different magnet in the rotor section, so it greatly simplifies the Altronic V. The Altronic III is also in process of being upgraded to that type of circuitry and triggering, so it's currently being tested. Okay, following literature that we reference is all available on our website, just so everybody knows where it is. When you go to the download section, you'll come up with a menu, and this is just a portion of the menu. And under Ignition Systems General, it starts with the general ignition products and different firing pattern codes. Then we go to accessories, then 1, 3, and 5. And when you click on 5, it's going to have the Altronic V brochure, the application list, the installation instructions, and service manual. And all of the products are set up in a similar fashion where they start out with a brochure, application, then installation, then service. So all the literature is there and available to you. We won't cover all details today because it's just too much information, but that's where a lot of this is being taken from. So the application list, and you can see this for the Altronic 5, 1 to 6 cylinder engines, done in 1995. The required items, we're going to start out with the Altronic 5 unit, and then we have two options, single and double firing unit. And single firing means that it's only going to fire on the compression stroke, which means that, on a 4-cycle engine, it's going to fire every other revolution. And a double firing unit is going to fire on both exhaust stroke as well as the compression stroke. So when you install them, you're going to wire them differently. The double firing unit is going to have 2 coils in series, and it can save you some money on the cost of the unit. The way it's wired in series with the coils, you don't sacrifice too much energy into the exhaust stroke piston and cylinder because it doesn't have any demand on the spark plug. So most of that energy is shifted to the cylinder that's under compression. So you can choose either one. The time that you cannot use the double firing unit, that is on turbocharged engines, higher performance engines, where some of the exhaust overlap can cause some firing into the exhaust system. So again, if you've got the choice, a single firing is a better choice. Double firing saves you some money and can be used when you don't have a turbocharged application. The wiring harnesses are specified on the next pages. The ignition coils, you have 2 different coils plus some shielded coils as options. We'll go over shielded systems also. And then other optional items, you've got the electronic timing, shielded system, then obviously from the instrumentation, 30, 40 years ago, almost all the control panels were powered by the ignition system. Nowadays, almost everything is DC powered, but you can still power a lot of our instrumentation from the shutdown lead of an Altronic 5 or an Altronic 3. This is part of the application options, as you can see in the top right. And this is the electronic timing option. And the Altronic 5 unit, you add a T before the dash in the part number. So a 6834 becomes a 6834T, then the dash A for the coupling and mounting dimensions. Timing units, there's only 2. For the 2 through 3 cylinder, it's the 581-603-1. And then when you get into the 4 through 6, it's the 603-2. So there's only 2 options with the timing units. And then the harnesses for that plugs into the timing connector. It's the unshielded or shielded. Those are the only 2 options there. And then this is the part number of the shorting plug for that T connector. If you're not going to engage in one of the timing units yet and you just want to put a shorting plug in, or if your spare has a T connector and you just need to use it without the box, you just have to make sure you have the shorting plug.
Tom, sorry, could you explain which is the difference between dash 1 and dash 2 again, please?
The terminals on the back are a little bit different, or on the box are different, but the 2 through 3 cylinder use the 603-1, and the 4 cylinder through 6 cylinder require the use of the 603-2. The box itself looks the same, just the terminals are different.
Thank you.
Single and double fire options, and this is part of the application list, and this is just under the Waukesha's. And the 3 columns for ignitions here is Altronic 1 or 1/6 kit available, the Altronic 5 single firing, the Altronic 5 double firing, number of coils, and any notes. So the first thing to look at, and first of all, an Altronic 1/6 is an Altronic 1 that can be either, depending on whether you have a mag drive or not. The Altronic 1.6 has the option of belt driving the alternator. And when you do belt drive it, you're not triggering off that alternator section, the Altronic 5. You're triggering off the Altronic 1 pickup coil assembly, and typically that pickup is mounted on the front of the engine with a disc with magnets in it. So this is where you can find that there might be even a lower cost alternative than the Altronic 5, and sometimes people will like to have the Altronic 6. But again, it's not self-contained. It's got belt-driven alternator, pickup coils mounted on the front of the engine. It's a totally different system. So the single fire system, 6A34 in this example, 6-cylinder, even fire for the A. We'll look at these part numbers and what they mean a little bit later. And then the 3A64, which is the 3 output, and a different drive ratio, which is designated by the number after the A there. So these are the two differences. The harness is different for the two systems, 023 and the 041. Just you have to make sure you have the mating harness, and these are all unshielded harnesses. We're going to have a page we're going to talk about that is going to show you what you can use if you want a shielded system. The notes here are important too, because all these, if you just look at note number 4 for the 190 or 195 Waukesha, note number 4, and again, this is the AW, that's the one where you have to mount that gear on the back of that drive coupling. The next page, when we look at that, note number 4, the drive gear for the unit is this Waukesha part number such and such. We do not sell those drive gears, and depending on the different note, there are different part numbers. You can see different one for that one. Note number 5 is a different one, 019 versus 119, and so forth. So anyway, pay attention to the notes. Sometimes the customers, if they've had these engines for some period of time, they're going to know these details. But if it's somebody new or somebody with a new engine to them, they may not know these details. So keep this all in mind. Okay, the shield, yes.
On the waste spark firing, is it only on the even firing? Can you do it on the odd firing also?
Well, the Altronic 5 is only an even firing system. The waste spark really, once we get into the Altronic 3s, most people don't deal with a waste spark system because the engine's starting to get larger. You're spending more on the ignition, and truthfully, you could waste spark it even in an odd firing application. It really doesn't matter. But you have to remember that, an Altronic 5, whether you turn it clockwise or counterclockwise, it's always going to fire, like a 6-cylinder, divide 360 by 6. You're going to fire every 60 degrees of the back cover. And if you get into an Altronic 3 that fires 30-60, if you turn it the other direction, it's going to fire 60-30. So you'd have to alternate the wiring pattern. You might have to wire A to the second cylinder in the order. So there's some variations in that, and that's the extreme application where somebody would want to exhaust stroke fire with an Altronic 3. Okay, so the shielded system, we have lettered it A, B, the coils, the C, the harnesses here, the shielded coils, integral coils. D is the connection between the shielded coil and the spark plug. And I just want to make note to you, if you're not familiar with it, all of these harnesses, this is an MS connector. It's an MS connector here, military style connector here. But the connections that would go into this J box, which we typically do not furnish, these are all a 1/2-inch NPT, the pipe thread, where this can be just like a NEMA 4 type sheet metal box. This does not have to be an explosion-proof box. This is really just shielding it from anybody tampering with it, and it's not designed to keep any hazardous mixtures out of this box, because there's nothing arcing or sparking in this box. So everything is connected with those half-inch pipe thread connectors on these ends. Some of the literature has drawings on these harnesses, so if you need more detail, they're in some of that installation instructions. The shielded system, those A, B's, and C's, correlate to the harness, the coils, primary assemblies, and the shielded spark plug leads. So all those are designated here.
Tom, one thing we should note there on D, the shielded spark plug leads, is that the 593020 is for a spark plug that has a 1-inch well depth. We do make a 593030, and it's for spark plugs that have a 2-inch well depth. The reason we bring this up is because we have shipped these leads across the country and out of the country, and then find out that they're for 1-inch well depth and they got 2-inch leads. So just be aware that there are these safety leads and these stainless shielded leads. Plugs come in both 1-inch well and 2-inch well depth, so make sure you get the right lead.
Yeah, when I was going through this, I noted that, and these options, this literature's been done since 1995, and I don't think it changed in this section for a long time before that either. The only thing I could think of is that these smaller, lower cost engines typically use a shorter well depth. They typically use a shorter spark plug, and there's no guarantee on that, as things have evolved, but that's the only reason I could think that this was only shown with a single 1-inch well depth on this D for the spark plug leads. So yeah, that's something that, once you've been in this industry for a while, you would ask those questions on the plug and the well depth. But to somebody that's newer to this, you would think that, well, this is going to fit everything that's an Altronic 5, and that's not absolutely true. Okay, now the identification form for the application list. This is going to show what the part number means for the Altronic 5. And the first is the number of outputs, and this is 1, 2, 3 through 6. Firing pattern A is even, and there's no option on the Altronic 5. It's all even. The gear ratio, the next number, in this case it's a 2, so that's a 2-to-1 internal ratio to the Altronic 5 itself. And there's going to be a difference when you look at the application list. It's going to show the drive ratio of the engine, the mag drive ratio. This is the internal ratio inside the unit. So just be aware that there's two different numbers you're looking at. And typically this is 1's a 1-to-1, 2's a 2-to-1, 3's a 3-to-1, the 6 is a 1.5-to-1. So we'll keep that in mind when we go through and we see an example. The next thing is the capacitor size, and this is not an option. You can't make up your own part number and choose your capacitor. This is designated so that it's properly sized for the application. And then the options, I'm not sure exactly how the H got in there. I think we originally thought we were going to produce some H's, and I didn't see any in the application list, but it's possible moving forward. But now we have the NG, so I'm not sure how that'll all evolve. But the T option, that's where the T would go in that part number. Then the mounting, and again, for the different engines, it's guiding you in that application list which choice to make for the application. And this is the another view of the Altronic 5s with the A flange, the A, M. And I just want to note to you, in the service instructions, when you assemble this and line up the back cover for the timing marks to align, it's going to tell you that this coupling position should be at a certain position and direction. And typically, the reason that we do that is so that the engine OEMs can assemble their drives in a certain position so that when their timing marks line up, their magneto drive lines up, and they can basically line this ignition up on the back cover and put it on, and everything goes right into that engine. But over the years, if anybody has disassembled that magneto drive and put it in a tooth off or 180 off or something else, when you go to put an ignition on, you may not be able to line that coupling up like you would like to. So the only thing you can do is to line up the coupling, bolt it on, then remove the back cover, line up your timing marks, and then put the timing back cover back on. And once you do that, you still may be off a tooth, and your timing marks may not still be lined up perfectly. And that's once you've done that, it's enough to start the engine. Then you can rotate it. Obviously, you would loosen the bolts that hold this and allow you to rotate the unit. And when you do that, it's just like moving a distributor on a car, timing it. And you're going to adjust that timing, looking at your timing light and on the crankshaft, and rotate it till your timing's where you want it to be, and then tighten your bolts again. So that's the reason for that orientation, but it's not always going to line up on you on all engines.
And that AW or GVW, Tom, that extended shaft is usually it's there for a gear that the OEM has made. So in the case of like a Aero 330 or a Waukesha 330, you'll loosen that bolt and that washer, mount their gear to that Altronic 5, and then mount it to the engine. So that's pretty much why the extended shaft is there.
Correct. Yeah, we noted to you that in the notes section that all those gears are supplied by the OEM, and we do not supply those gears. So that's a pretty typical accessory that you have to get from Waukesha or CAT or whoever it may be. So this wiring, if you look at the output of this harness, and you'll see that you've got one wire that goes to the first coil, then the second wire to the second coil, D wire to the third, and so forth. If these coils were wired in series, you'd have the first and fourth wired from plus, and then the minus would go to the other plus, and so forth. So typically, you're going to wire them in series for those kind of applications and save you some money on the unit. But if it were my choice, and you know, the cost savings, and I checked the price, and it was maybe about 10% less costly to go with the exhaust stroke firing unit, I would choose a compression only firing if cost was not the sole issue. So magneto drives were originally made because of the limitations of true magnetos in the old days. And, you know, Altronic started with these systems in the late 60s, so we had to adapt to the existing mag drives on all engines, and it's somewhat been the standard moving forward. And the mag drive ratio is in relationship to the engine crankshaft. So a 1-to-1 is the same as the crankshaft speed. 1.5 to 1 is going to turn 1.5 times the crankshaft. And the whole goal on a 4-cycle engine, you have to turn the back cover just like a distributor, and it has to turn at crank speed for an exhaust stroke firing system, and a 1/2 to 1 or cam speed for a compression only firing system. So the internal gears in the Altronic 5 get the back cover turn at the proper ratio. We just go back to the installation instructions, and if you look here, you can see that we don't show it until we get to the Altronic 3, so we'll show you that when we get to the Altronic 3. So now we're into the ignition coil options, and we've got the blue coils, the 061s, the O10s, which are the red long duration, then we have integral coils. And if you look at the max kV open circuit, you've got 34 kV on the two coils, the blue and the red coils. The duration is different. Long duration is going to stretch that spark out, and it doesn't have any real magic in it to give you more energy, total energy. It's just going to stretch that spark out for a longer period of time and have a little bit softer initial energy in the coil. So some people on lean burn engines, and most of the applications you'll see lean burns are going to recommend the red coils, the 591-010 or the shielded variation of that, and that's going to give you some longer duration. And integral coils, because they are physically smaller and they screw right onto the spark plug, the max kV is only about 20 kV and the duration is shorter than the blue coil. So integral coils are a good choice where you have to have shielded ignition system and you want something that's quite simplified without a shielded secondary lead. And sometimes because of the well in the depth, these are nice because they screw right onto the spark plug and get the connection for the MS connector right outside of the well. So it makes a nice convenient option. This is a view of the three different coils. We've got the blue, and then this is a red coil if it's the long duration. The shielded coils, basically the same windings, just put into an explosion-proof housing. That is the shielded variation. And then the integral coil, and this is the somewhat odd one. We don't use these too much because this 591-007 with these male threads into an expensive spark plug. So almost all of the coils you'll use with a 5 or a 3 will be the 011 A, B, or C. And those coils have the female thread that thread onto the lesser expensive shielded spark plug. So what are you going to choose, an Altronic 5 or the Altronic 3? If it's 6 cylinders or less, you can use either of them. If it's above 6 cylinders, you have to go with the Altronic 3. The 5 is less costly. The 5 has less spark duration, but it's adequate for most applications. Lean burn and poor quality gas requires more spark energy, so if it's lean burn or turbocharged, you're going to want to make sure that you have the compression-only firing version of the Altronic 5. All of the Altronic 3s are now high output or have an H in their part number, and they have more energy and spark duration than the original Altronic 5. The new Altronic 5 NGs are starting to rival the energy of the Altronic 3, so when we get into that, Matt Trina will have some slides to show you. But if we look at this under Altronic 3, don't look at this standard output because those no longer exist for new applications. All Altronic 3s have been H or high output for probably almost 30 years now. So when you look at the spark duration of a standard coil 5 and 34 kV max, here you got 40 kV, 180 microseconds at 10 kV, and here you've got 300 microseconds. So you have almost double the spark duration with an Altronic 3. When you have the long duration coil is 450, here with the 5, here it's 550 with that long duration coil. So again, the Altronic 3 does have more energy versus the legacy Altronic 5.
Tom, one thing to note here on that, if you can go back, that's a slide, is that for the duration, it's nice to know the KV too. In the old days when we used to have a lot of competition, Denelco and Bendix and so forth, they used to tout long duration, longer than ours, but then they'd never give you the KV. So to talk duration with the competitors or even in between ignition systems, you really need to know the kV or the voltage it takes to ionize the gap of the spark plug. So here it's actually shown, and that's good. So I just wanted to bring that up.
Yeah, and somewhat of the industry standard is at 10 kV, which is pretty close to what a demand would be with a brand new set of spark plugs and a smaller gap in the engine. And obviously, as the spark plug wears, the kV goes up and up and up. And, all of our coils the worst case with the 5 and what you can deliver is, 28 kV with an integral coil and 34 kV with the 061 or 010 coil. And typically, a spark plug is going to arc over somewhere between 25 and 30 kV. So we have more spark energy or max kV energy than any spark plug that you can't deliver any more than the spark plug can contain and insulate. So all these coils can deliver way more than you can deliver through a spark plug. So, and the ratings at 10 kV, that's pretty much a standard when you're comparing apples to apples. So if you have an engine and you don't know what ignition to choose, whether it's the 1, the 1.6, the 5, or the 3, DC powered ignition, disc trigger, like the DISN, or the crank trip reference like the CPUs. So what do you look for? You look at the application guide. And that application guide gives you a list of the different engine manufacturers, alphabetical, the number of cylinders that these engines are, whether you can use and the nomenclature here is either an R or an O, recommended or optional, and it's like in the case of, say, this, let's just choose how about a Caterpillar? And you can use one on 4 to 6 cylinder. It's optional of the 1, 3, or 5. The recommendation is the CD1 or CD200, DISN, or CPU95. When you get into the smaller engines like an Ajax, you can use an Altronic 1, 3. Typically, they don't use the 5s. Not sure exactly why, but obviously this sort of gives you sort of a guideline if you're not familiar with the engine manufacturer and how many cylinders it might be and what options you might use for an ignition. The picture you see here with the Altronic 3 and the electronic timing options, this box, as you see here, it looks similar. You might be able to tell there's more wires because this is probably for a dual circuit Altronic 3. There's more terminals on it, but it's the same sort of function. When the pickup coil starts to turn on, you can use the influence of this box with the potentiometer and adjust that so that you get some timing retard. Disable it with connections on the connector here. And again, if you don't have this box or these connections, you have to use a shorting plug that plugs into this and shorts some of these terminals out. That's the same thing as what you would do on here when you would disable the function of this box. The other two boxes you see here are somewhat outdated, but plugged in with another harness to that same timing connector. And this was a 381-610 box, and these had programs in them to give you a timing versus RPM curve, and these were used on mostly Superior engines. And the different variations of the Superiors, in order to meet emission standards, they had a RPM curve where at certain RPMs they'd have different timing. So now in the CPU95s, we duplicate those same timing curves and build it in and program it into the CPU95. The other thing that you see here, this was the Altronic 3 CPU, and again, it connected in through this timing back cover. And this was the very first CPU that worked with the on time of those pickup coils in the Altronic 3, and it had a reset and gear teeth on the flywheel like current CPUs do. But you fired through the Altronic 3, and the output circuitry was still the Altronic 3, but it was electronically triggered and timed, so you had more accurate timing, but you were still using the output circuitry of the Altronic 3. So it was somewhat complex. It worked well. It was somewhat complex to time. And once the CPU 90 came out, it really replaced the 3 CPU. The 3 CPU is now obsolete. The 610 boxes are almost never ordered new anymore because most people with that type of an engine have gone to a CPU 95 by now. So the Altronic 3 has the same style of removable back cover with the multiple ratios. You have a drive gear in the alternator, driven gear on the back cover. You have a timer arm that goes past pickup coils. You have a circuit board in the back cover. All of these are replaceable items. And the only thing you have in this front housing is the alternator windings, the rotor coming through, and then a full wave bridge on the connector here, which plugs in there to the back cover, and then it's placed on the unit and bolted together. So again, most people, if they had the choice, they'd take a complete Altronic 3 to the field to replace as a replacement if they had some failures. But if you want to, you can replace the back cover in the field. It all depends on how much stock you have, what stock you have, and what your options are. Now the application list, this is where you can tell how this all works together. This column, and again, this is Altronic 3 application list, and this is all the Caterpillar section. The drive ratio you see right here is the mag drive ratio on the engine. So a 1.5 to 1 is going to turn 1.5 times the crankshaft speed. It's a clockwise drive. It's a 6A39, and this number after the A is the internal gear ratio, which remember the 1, 2, and 3 were either 1 to 1, 2 to 1, or 3 to 1. So a 3 is a 3 to 1, and if you take a 3 and divide 1.5 by 3, you come up with 0.5 or 1/2, which means the back cover drive is going to turn at half crankshaft speed, which is the same as cam speed. If you go over to a 1-to-1 unit, this is turning the same as crankshaft speed. Internally, you have a 2 to 1 gear. So again, 1 divided by 2 is 1/2. And that's pretty much how you divide these out. The 2 to 1, if you go over here to the 4 to 1, internal drive, 2 divided by 4 is again 1/2. So this actually shows you how those two are related. And the other thing to look for in the application list for the 3 is that you have both clockwise and counterclockwise options. And obviously an even fire, like a 6A, you can turn it clockwise or counterclockwise. It won't matter. When you get down to some of these where you have choices, whether you have to choose a clockwise or counterclockwise application, you may find that, especially on the odd firing applications, you may find that you have to know the drive rotation direction. And remember, you have to look at these drives as if you're inside the engine looking out through the magneto drive, which is sort of an odd way to look at things because it's somewhat hard to visualize that, because if you walk up to the engine, you see the shaft turning clockwise. If you look in through the shaft looking into the engine, and then say, okay, well, if I were inside the engine looking out through the shaft, it's just the opposite drive. So that's the convention for that magneto drive. And we didn't decide that. That's something that was decided by the magneto and the engine people many, many years ago. So we just have to follow that same convention because it's been accepted throughout the industry over the years in numerous publications and magneto books and everything else. This also, the Altronic 3 number is also going to give you an unshielded wiring harness. So that has to match to that application. The number of coils, the notes, the S means that it's a single capacitor ignition. The dual means it's a dual cap. And in the case of a dual cap, you're only going to look at the shutdown lead is only going to look at half the number of cylinders internal to the unit. So if you're synchronizing a tachometer to the shutdown lead, you know, a 16-cylinder dual capacitor, you would synchronize it to an 8-cylinder type or an 8-cylinder setting on your tachometers. So again, pay attention to the notes. They mean something on many of these. You have all the way through note number 24. And then again in the part number.
Hey Tom.
Yes.
Is it okay if we just go back to that? You could leave it on this slide, actually. I just want to touch on one thing you were talking about the mag drive, the gear ratios, and clockwise to counterclockwise.
Yes.
For some people who've been around this a long time that definitely know it's pretty ingrained in your brain. But someone like myself who wasn't around it a lot, I just want to add maybe in terms of the troubleshooting or some of the aspects of how to look at that. When you touched on the gears and you touched on the clockwise and counterclockwise, and if you look out versus in, but if you think of yourself looking out, like Tom mentioned, you're looking out the engine into our Altronic ignition or the magneto, and then when you turn yourself around and you look at the back of the ignition or magneto, it's actually spinning almost in the right direction. And don't forget that gear ratio in there. If the gear is spinning as you're looking out clockwise, the other gear in there is going to spin counterclockwise. So when you turn yourself around, if you're envisioning yourself looking out, and then in order to actually look at the ignition, you're looking at the ignition, there's that 180 flip, and it takes care of it in the gear ratio. So if you're trying to figure it out and you're saying, well, I'm looking out, but it's doing the wrong thing, it's probably because you forgot about the gear ratio in there, that if you have two gears, one spinning one way, the other spinning the other way. So make sure when you try to figure out if there's a question on that you're thinking that this spins and then I have a gear in there, so it has to spin the other way. And just don't forget about the two gears as you flip yourself one way versus the other. So hopefully that made sense.
Yeah, I know exactly what you're saying, Matt. And if it's difficult or it's confusing, sometimes one of the simplest things is to like draw a picture of of the engine and the shaft coming out, and just draw some arrows of directions, and then know that the gears inside, one gear turns one way, the other gear turns the other way, and you're going to change the direction, and your frame of reference of whether you're in the engine, outside the engine, or looking at the back cover, all that gets very confusing until you get familiar with it, and then it's just second nature. So the part number designation, like the 5, is very similar, except that the number of cylinders doesn't stop at 6, it goes all the way up to 16. The firing pattern, the second letter is not only an A, but it can be a B or a T or various other numbers. I'll show you what those numbers mean. The next one is the stator winding. And again, because this magneto drive can be 1/2 to 1, 1 to 1, 1.5 to 1, 2 to 1, we have to be able to build these so that we can make enough energy in the stator so that we can charge the capacitor. And you can't do it with one single stator winding, because some of them are turning half engine speed and some are turning 3 times engine speed. So what we do is we have different stator windings so that we put it in there with different rotors and different magnetization, I guess you'd call it, for different ones. And we produce the right amount of energy to get that capacitor charged up at full rated speed. So again, can't pick and choose your stator winding. We designate the right one for that application, and that's the part number of the stator that goes in there. All the options there, they're all H's now. We don't make one without the H. The T is an option. And then the next one is the mounting, the A, B, E, L, D, E, L, G, and so forth, with all the different mounting variations. And, if somebody's replacing one of these, the part number on the existing Altronic 3 will have all these numbers. And again, that's the key. If you can look at the application list and say, well, if I have a CAT 399, this is the unit that should fit on there. It's a pretty sure thing. Those have been around for a long, long time. But if somebody has the current part number of the ignition on the unit, that's even a better confirmation of what is correct for that installation. Okay, the firing pattern codes, that second letter, and once you get into the different installations, you've got the threes, they're all an A, and it's all 120 even. But once you get into the four-cylinder threes, you can have a B, an F, a G, and an S, and these correlate. In the Altronic 2 is obsolete now, but in the Altronic 3 column over here, we don't make a 4B in the 3. We make a 4F, which fires 63 117 clockwise, and again, these are in distributor degrees. So if you look at a three-cylinder 120 even, that's going to fire 3 times in the 360 circle, which is the back cover speed. So you're going to have 3 firings on a 4-cycle, but that's going to be 2 revolutions of the crankshaft on a 4-cycle. So again, these are in distributor degrees, and these are the degrees between the different firings. 6-cylinder, the even is 60 even. The 6B is 90-30 clockwise. And then if you look at some of these down here, like the 8G, it's 75-45 clockwise, but 45-75 counterclockwise. So that's dictated by the position of the pickup coils in the back cover. And these are things that are mechanically fixated in that back cover with precision in the pickup coil location. And we can maintain in those pickup coils plus or minus 1 degree of mechanical position. And that equates, depending on the drive ratio, 1 degree in the back cover at distributor degrees can be 2 degrees on the crankshaft. So obviously, the accuracy of these back covers is limited by mechanical placement. When you get into the CPUs, that's where you get into this more accurate crankshaft reference timing, and the Altronic 3's plus or minus 2 degrees on the crank by limitations of the manufacturer of the unit. Then you have the drive gear, the drive coupling, the drive, everything that relates to get the crankshaft to drive the mag drive, and the slop in that. So you can have, 2 degrees can become 4, 5, or 6 degrees on the engine itself as the engine accelerates and decelerates, and you see all the slop in those gears. So again, that's what has led to the success of the CPUs and the crankshaft reference timing. So unshielded coil choices. This is the red coil, the 010 coil. It's made out of an epoxy for non-hazardous areas, bolted to the engine or a common header. The 061 is the blue standard, and the red is the longer duration. Use that with unshielded spark plugs and unshielded leads. And this would be typical on engines that are out in the field where there's no hazardous area requirement. There's nothing arcing or sparking on the primary side of these. Everything is solid terminations. There's nothing arcing or sparking in the ignition. The only place you can really have that occur is if the spark plug lead were to come loose or to arc and break down and arc against a head or another piece of the chassis of the engine. So these are typical for like field engines where there's no hazardous requirement, or on engines that might be on driving generators, typically where the natural gas is the fuel and you're not compressing it. Shielded coil, again, we have those same coils in the 061S, 010S, either the blue or the red, just encapsulated in the stainless steel metal can, and those meet hazardous area requirements for Group C and D Div 2. So ignition coils, over the years we've had competitors build coils. We've had them manufactured overseas, different places, and most of those coils are inferior to the Altronic coil. And we match those coils to the systems that we're designing. So they're not a commodity. So when you substitute, or a customer substitutes somebody else's coils in there, they may not be getting the performance of an Altronic coil. What you're looking at is the maximum available voltage, the current in the arc, which affects the quality of the combustion, the spark duration, again, the quality of the combustion, the rise time, and misfire reduction. So these are long-term investments. They go 24/7. Some of these things are on for 10 and 20 years, sometimes longer. So it's money well spent getting Altronic coils versus saving a few bucks on competition. And again, you always want to use all red coils or all blue coils, and it really pays to match them to the Altronic system. So the installation of the 3 or 5, we're going to talk a little bit about that. This is the counterclockwise and clockwise marks on the back cover. You would roll the coupling over to where the proper rotation would line up, and at that point you're going to verify the engine timing with the timing light before you shut the engine down if the ignition is just being removed for a maintenance schedule or new bearings or whatever. So if you can, you want to make sure you know the proper ignition timing for that engine, that load, and that application. So fuels will dictate that, the load on the engine, the atmosphere you're running in and such. So you always have to know where your engine runs. So you're going to turn the flywheel over till the correct timing mark, for example, 22 degrees before top dead center. That's where the engine fires on your, and you're going to line up your timing marks on your engine and your flywheel, a number one cylinder on the compression stroke. And at that time, and you're replacing the 3 or 5, that mark on the back cover of the 3 or 5 will be lined up either clockwise or counterclockwise. You would, at that point, you would remove the old ignition, and if it's a legacy 3 or 5, you line up the proper counterclockwise or clockwise red mark, and then you would put that ignition back on. If it's an NG ignition, and as you see on this back cover, the counterclockwise and clockwise, there's only a single mark on the new ones, and then the pointer on the shaft, you would line that up, and that's going to be a little bit different on the NG Altronic 3 or 5. So you'll have some different marks. I think on the 5, you line it up in between the 2 marks if it wasn't manufactured here at Altronic. So just a few little differences, but and again, if the coupling doesn't line up at that point, you basically have to line the coupling up, remove the back cover, put it back on. So once you install the new 3 or 5 with the 2 red marks lined up, you adjust the coupling until it lines up and reinstalls it. This one is a figure 8 coupling on a base mount unit, and this is not the flange mount with the pilot. So these have this is what we call the BEL, or the adjustable base. So there's a bolt right here, and it allows the 2 halves of this Altronic 3 to rotate. So you would line up the couplings, mount everything together, make sure your marks are lined up on your back cover, and then once you start the engine, you're going to loosen this bolt and rotate the Altronic 3 a little bit till you get your timing dialed in, and then you would tighten that bolt back up. And the BELs, or the EL bases, are not as common as the flange mounts, but they are out there. There's a coupling that mounts on the shaft of the engine. It's got keys in it. There's a number of different ones for different size shafts. These were original Bendix parts, but we do sell them. And then once it's on there, the bolt that goes through here is going to adjust and bolt everything together. You got some pins that go through the engine mounted piece and pins that go into figure 8 coupling, and everything bolts together. But these are a little more flexible because you can adjust this mount onto this shaft where this goes on and the bolt goes through there.
Yeah, Tom, when I put this on the Waukesha 7042 for the prototype, that coupling, once we pulled the pins out, was quite a bit out from where the Altronic 3 was at. So obviously the two lines are lined up, and we were probably 160 degrees out. So just by loosening that bolt up at top on the metal coupling, and if you see the hub there,
that's this one right here.
Yeah, we loosen that up, and then the hub has the threads built into the side of it.
Right.
Put the arrow, and then you just turn that bolt, and that coupling will actually walk its way around, rotate until you line it up, and then you pound the pins in, tighten the bolt up, and you're good to go. So those little thread things in the hubs are actually to help you spin it around the engine shaft. So that's how that works.
Right. This bolt that you see over here is that bolt. You got a nut over here and just a bolt through here. And when this isn't perfectly lined up, but the center of this bolt as it goes through is lined up with the center of these threads here. So, in order to put it on, you have to take the bolt out, put it over that hub, and then when you put the bolt through, you can spin it and rotate it and adjust the alignment.
Correct.
If you had one in your hand, it would be pretty obvious that, what you've got to do, but just looking at pictures, it's not always obvious. Okay. So you line that coupling, start the engine, check the timing. So obviously, because of the gears and the alignment there, you can be off 5-10 degrees. And sometimes you have to remove the back cover and move it a tooth. And sometimes you can just rotate the unit enough. But like in the flange mount units, the amount that you can move, because those slots are only so large, if if you put it in the center of the slot, you got to rotate it to the one side and you just can't get to where the timing is. That means you got to move it back to center, pop the back cover off, move it a tooth, put it back on, and then you'll have more range in where you want to change your timing. So in this case, you loosen that slide on top right here, just rotate the ignition back, totally rotates. The split is like right here. And this stays mounted to the flange, and there's a bearing in here that allows the two halves to rotate. But again, you're always going to have a timing light when you put one of these on. So there's all these different mag drive arrangements. This shows the figure 8 coupling and the drives. You can also have it on this type of GL flange, but those are not quite as common. Just quite a few variations in those different flanges. Some of the other ones that we hadn't seen in the previous ones are these, and again, the O's, that's an O-ring flange. There's an O-ring on here. The other ones just have gaskets, like a paper gasket. The other one that's different here, this is for Waukeshas. They have that coupling. They've probably seen them on some of the CPU drives when you had an alternator on the CPU 2000s or CPU 2s. Those couplings, Waukesha has adapted that coupling also for their drives. So the other one is this J flange, and that has I think most of them have an O-ring, and this is for some of the newer Caterpillars. So a lot of different variations. So now we'll talk a little bit about some troubleshooting tips. The first thing is you have to have a good description of the problem. Like taking your car into the dealership, like Mike I think said, saying, "Can you fix my car?" Well, what are they going to fix? Is it the tire that's vibrating, or is it the engine won't start, or is it overheating? You have to have a good description of the problem. Like the engine's running along, it's pulling full load, and all of a sudden it just starts to misfire. Or the engine shuts down and it's hard starting. or one cylinder quits on you, and which cylinder is that? So a lot of these questions, you have to determine whether, the engine's been working, which it was originally installed correctly, or if it's a new installation, did somebody miswire something? So those are all things that, depending on how new the installer is, whether it's the end customer doing it, it's his first time, and maybe doesn't know some of the details of the installations, you have to ask all those questions. But if it's run for some time and then the ignition quits, sometimes you have to sort all those things out. So if the engine runs, what is that observed issue? Overheating, wrong timing jumps, is it coupling issues or whatever? So if the engine won't run or has quit running, one of the first things you probably want to do, if you crank the engine over with the starter, do you see the back cover timing marks rotating? So if they're not rotating, obviously the coupling could be bad. And on a flange mount unit, that's all embedded behind the coupling, or mount, so you can't see it. It could have sheared the lugs off that coupling, and it's just not rotating anymore. So the engine came to a stop, and the thing's just not working anymore. Are the red timing marks on the back cover aligned at the proper timing? So you rotate the engine around so the timing marks are aligned, and if your timing marks are aligned on your back cover, then you haven't shifted any timing, because of a coupling. So now, next question is, if it'll start, does the shutdown lead have a proper voltage on it while you're cranking? And then if it's proper while you crank, is it good once you've started up? And those proper voltages are all listed in the service manuals. Those can all be checked with a voltmeter. That's one of the tools that the two tools you'll probably need is a voltmeter and a timing light. The timing light is nice because it's non-contact. You can just clip it on the spark plug lead or the ignition primary, and you can tell whether you're getting firing to the plug. And if you're not getting it to the plug, then you can check to see if it's going to the coil. So, and again, intermittent missing can be due to shorting primaries, bad plugs, condition of all your wiring. The wires on these engines, often they get put on, painted, heads are changed, maintenance is done on the engine. Sometimes wires get pinched and abraded. Some engines are out in the water and weather and sun, and the wires get cracked and abraded. And if they come in contact with a block and are wet or damp or whatever, they could be arcing to the block. So again, all those things, you want to make sure the ignition and the wiring is all in good condition.
Tom, let me mention something for somebody that's maybe brand new on the phone call here. When we put this on the Waukesha and we wanted to bar it over to 22 before top dead center, we did that, walked over to the ignition, and the red line was nowhere near the red line to line it up. It was basically 180 out. So for anybody that's brand new, we knew that the engine was not on compression stroke but on exhaust stroke. So we then had to bar the engine over another 360 degrees, and then it lined up dead nuts with the 22 before top dead center. So just wanted to mention that for anybody that's new on the phone.
Yeah, unless you have some easy way, like big engines will take a valve cover off and watch valve opening to see if you're on compression stroke or not. But if you don't have some, the piston is going to be, 22 before in two different positions, one's compression, one's exhaust. And if you don't have any easy way to do it, it's not always easy to tell. And if the ignition's still on and good and working, that's the quickest, easiest way to know whether you're on compression stroke or not. So common tests done with a timing light and usually a digital volt ohm meter. Check the firing on the secondary with a timing light, as well as for the proper timing. If the timing light will not fire on the secondary. That could be because the spark plug is fouled, and if it is fouled, it doesn't build up enough energy in the coil to create enough energy to trigger the timing light. So a fouled plug will not allow that to trigger the light. So if then you put the pickup for the inductive pickup of the timing light on the ignition primary, which is, the 16 gauge wire that goes to the coil, and that may be right at the coil, or it might be in the junction box. It can be anywhere between the ignition and the coil. And that is enough energy, the 150 to 200 volts as it discharges into the coil. And it's going to be enough to trigger that timing light. So you can basically separate the secondary circuit from the primary circuit. And if the timing light doesn't work on the secondary, then you're going to put it on the primary. And if it works into the primary, it's not the ignition unit or the wires going to the coil or even the coil primary. But the coil primary is very stout. They're heavy gauge wire, very low resistance, pretty big wire. If the coils ever fail, it's almost always in the secondary windings. So if it works on the primary but not the secondary, the first thing to do is change the plug. Check your wires at the same time, your spark plug wires, and if those are good, you can try it again. If it doesn't work at that point, it's worth it to change the coil because you could have failed the secondary windings in the coil. So it's pretty easy to methodically use the timing light and sort out whether you have a problem in one cylinder or not by just using it and cranking the engine and looking at the timing light on the secondary and then on the primary. At that point, if you're still having trouble, you can hook your volt ohm meter up and set it on a high enough voltage scale, or if it's auto ranging. When you look at the shutdown lead, which is the G lead, or it could be a different letter in the alphabet depending on whether it's a 5 or 3 or CPU 95 or whatever, and you're going to look for the proper voltage. And that voltage, you're going to read an average of that voltage because of the way the voltmeters work. And typically, in the old days, you always looked at that voltage with a meter, you knew what was normal. And at certain RPMs, that voltage will be the same, but you have to realize because it's charging and discharging constantly, different RPMs will yield different voltages on your meter. So you can't check it at idle and expect the same voltage as the unit increases in RPM. And actually, usually at idle RPM, you'll have a higher voltage because of the wave shape than you will at a full voltage or a full RPM of the engine. It might be 1,000, 1,200, 1,500 RPM because just the way the storage capacitor charges and discharges and the wave shape, the meter will actually decrease, the voltage will decrease with increasing RPM. And that might lead you to think that there's something wrong with the ignition, but if you would look at it with an oscilloscope, you would realize that it's still charging properly and you're getting to the right voltage. But that's a lot of times oscilloscopes in the field on a field engine with a 3 or 5, it's just not practical, and almost nobody will use a scope for that purpose.
One thing that I want to mention, Tom, on the coils, I've got calls on these coils where people think they have a problem with a coil and they'll measure the secondary, which is fairly easy to measure because it's, say, 6,300 to 7,200 ohms, which is easily measured by a VOM. But a lot of these people have fairly cheap meters in the field, and when they go to measure the primary, which may be 0.2 to 0.5 ohms, the meter's not actually capable of measuring that low of a resistance. So when they get 4 or 5 ohms, they think they've got a bad coil, and it's not necessarily the case. It's just that the meter is not of a high quality device. So in that case, I tell them to either measure another coil next to it, or if they really think they've got a bad coil, swap it out with the cylinder next to it and see if it follows it. But just be aware that measuring the primary with some of these meters is iffy because of the low resistance.
Yeah, the other thing is that the secondary, you can use the specs in the manuals and measure the secondary, and you might get the right ohm reading on the secondary, but under load, those secondary windings, which are very, very fine wires, they're actually arcing over internally. So because the meter only has a small amount of voltage, it's got a 9-volt battery in many cases, you're not going to have enough voltage to arc over those secondary windings. So you really can't check the secondary you can check to see if they're open or, within spec. But if the coil is failing with increasing kV demand, it's very likely that those secondary windings have failed. So, these coils, again, the easiest way in the field is to substitute in a known good coil for what you think is a bad one, and you can move on from there. So some of the other troubleshooting when a unit is aging or the installation is aging, often those are coupling failures. And when you have an engine, obviously your maintenance schedule, you're going to know how often these engines are failing the couplings. The couplings don't last forever. Some may go 6 months on a coupling, some may go 2 years on a coupling. It all depends on, how often the engines are run, the heat, drive, whether it's got a lot of chatter in it or not. So obviously, this is part of a maintenance schedule. You don't usually wait till a coupling fails to change it because obviously you don't want the engine going down. The other thing is primary wires, they can short if they get old and crack, or if there's vibration, allows them to chafe. Again, you got to replace these harnesses. Sometimes you go out there and it looks like they've been out there for 40 years. And, inspection, and, if they are chafing and they're not tied up well and they're starting to crack, sort of the rule of thumb is if you bend the insulation, by bending the wire and the insulation cracks, then it's time to replace it. And spark plug wires need checked and replaced as necessary, and they surely don't last 10 years. Spark plug KV can really degrade the insulation on these secondaries. And, in your car in the old days when you had a V8, you replace your wires every 30, 40,000 miles. And that wasn't very long because at that point, if you got any moisture in the engine bay, you were arcing the ground. Insulation degrades. Same with all these wires that we see on these engines. You don't want to mark in the ground, so
I put that in there, Tom, to remind me that we had a customer that had a fire, and they hadn't changed these leads, these secondary leads in over 10 years. And you mentioned 40, 50,000 miles on a car, and these engines run 24/7 in a lot of cases. And in 1 year, that's over 500,000 miles. So this particular customer, which I won't mention, had over 500,000 miles on this engine. So, had 5 million miles on this engine. And once they went in there, shut the lights out, and did the night test, it looked like the 4th of July in this engine room that had the fire. So just be aware that these engines are putting 500,000 miles on a year at 60 miles per hour. So they just can't hold up to 10 years.
Yeah, the other thing too is, a lot of these engines, especially once you get in towards lean burn, the KV demands is so high that, the higher the performance of the engine, just like a high performance engine in a car, it's going to break more quickly, parts are going to need changed more often, and leads are going to degrade more quickly. So the higher the KV and the higher demand on the ignition, the more often these wires are going to need changed. There's also, but they're somewhat geared towards bench testing and fixing a unit in a shop. But troubleshooting guide you see here, it gives you the problem in the left column, one output's not firing, and tells you how to use the ohm meter lead, where to put them, what scale, R times 10,000. And this is something that you may have to actually even use an old analog meter like the old Simpson 260. So a lot of us in this business still keep one of those around just because it's got enough energy to do some of these things where a digital meter won't do the same kind of work. So just be aware that a lot of these things are in the service manuals. but they are somewhat geared towards a bench repair. Okay, the Altronic V NG, and when you look at the back cover, you see that there's one pointer on this with one red mark on the back cover. Back cover looks just like the other one, almost no difference in the look, but quite a bit of difference inside and improved performance. I just want to point out before Matt Traina takes over is that this new generation, which is what the NG stands for, is the literature just past the Altronic 5 is the 5NG, and it's got five different pieces of literature: the brochure, the application list, installation instructions, the service manual, and then there's also upgrade instructions when you're doing a conversion between the original 5, the legacy 5, and the new NG system. So Matt's going to tell you some of the differences and improvements between the two systems, and I know we're building and shipping the NG at this point right now, so I'll let Matt Traina take it from here.
Thanks, Tom. Hi, everybody. Yeah, so as Tom mentioned, I'm going to cover the NG in a little bit of depth here, and I'm hoping outside of just explaining some of the differences and maybe some of the benefits, it'll actually help with some of the troubleshooting as well. So Tom did a lot of stuff in generalities, and as I go through, I'll kind of bring maybe a few things to light to look for at the NG level. And then before I get started, the other thing I want to touch on that kind of, as we talk about the NG and the 3 and some of the work that's been going on there, we have field tests out, and that's going to be released here into production very soon. As I was going through that, we'll talk about the application list here a little bit. That mainly a lot of these are 16s and 8s. A lot of them are 12s, is the majority of them. And when you get to the 12s and the 16s, that's when you can get into the odd firing patterns. And for just a little bit of troubleshooting tips there, Tom had mentioned earlier about lining up clockwise and counterclockwise. And if you're on an even firing, they would kind of go in the same, say it was a 60-degree firing unit, it would be 60 and then 60. And if you had a counterclockwise on an odd firing, say it was, 30-60 and then 60-30, the one thing to note on the Altronic 3s, and this became very prevalent to me as we were laying out the literature for the Altronic 3, is that depending on the engine and if it's spinning counterclockwise, when you want to go the other direction, if the application list calls for a 30-60 and then it's just to spin the other way as a 60-30, it's fine. But if it actually calls for, say, a 16 that needs to spin and be counterclockwise as a 60-30, it's important to note that you'll have to wire the output harness different. So if you're not familiar with these units, and you walk up and you say, well, that's odd, number 1 goes to A, but number 2 goes to T, or V in a 16-cylinder case. Why is that? And the way the counterclockwise of a unit that has to have the odd firing pattern is we always start with A. So I'll talk about A, and the reason I'm bringing this up in the NGs is because it instead of that red mark, and I'll show you here in a minute, it lines up on A. But the important thing is we always start with A, and then the second one in the firing order would actually go to the last one. So A is number 1, and then depending on your firing order, number 2 would go to the last cylinder, and then fall all the way around in a token ring. And that's just due to the mechanical nature of how it spins and us always lining up on A. And then, as you know, our output harnesses are A, B, C, D, and so on. And then you decode those for your firing order. So just one of those odd things that I came across, that if you come across it on an odd firing unit, it may cause you to scratch your head a little bit. So just be wary that A is always number 1 no matter what. And if it's a counterclockwise on an odd firing, there's a good chance you may find out that number 2 is actually going to the last one in the firing order. So go to the next slide, Tom. Thank you. Okay, so on the one of the major differences on the 5 This is not on the 3. So with the Altronic 3, Tom had mentioned the high output is everything now, and that's the same with the 3 NG. On the 5 NG, what we did was we replaced a nickel-based magnet with the Neo boron. So what that does is that gives us a much higher output. It's a ring-based magnet instead of that star pattern that you would see. And then it also presses onto the same shaft as the Altronic 5, and then you would move on and update the back cover with a new circuit board and label. So can you go to the next slide, please? So there it is, actually in a picture there. So what you'll see is we have a little bit more spacing around the magnet. It's actually physically smaller in diameter. You can see that on the picture on the right with the bottom magnet. So if you come across this, although it looks different and maybe presses the same, it actually gives us much higher output. And we'll talk about what that gets for us in terms of maybe some troubleshooting, as well as what that does for the output of the unit. Go to the next slide, Tom. Okay, so this is the circuit board as it sits. And one thing to kind of note here, and we'll just cover a few different things. So the circuit board is all integrated. So on the traditional 5, you notice that the circuit board was kind of standing perpendicular, had a bunch of through-hole components, and then the pickup plate. So on this, if you look here, you'll notice that everything is surface mounted. And to the right, there's where it says Altronic 5 and the part number. There's actually at the top there, at the 12 o'clock position is where we're always going to line up our magnet. And I've heard a little bit of feedback from the field, which is good, which means people are looking at this. That we're always going to line up with that Hall effect at the top there, which is our trigger magnet, as you want to call it. And there was a request to have a line on the magnet cup, and I've been looking into that into production, and I understand why that's needed, and we're looking at doing that in production. But then when I asked the question of how we were doing it, actually what it turns out is if you look at the magnet cup, there's a screw that lines perfectly up with the magnet. So for us, we do it exactly like you would in your shop, but we use the screw. So I understand that there is the need for the line to line up the magnet with A, but as of right now, there is an indicator. The screw, if you looked at the screw mounts with the gear, there's always one that's got a bigger angle, and that one-off screw in the center always lines up with the magnet. And if you line the screw up with that Hall effect, it'll always be over A. So just again, a little bit of troubleshooting there, a little bit of differences and how some of this works. But that is, essentially the circuit board you replace. You no longer have that pickup coil assembly. And you can go to the next slide, Tom. And feel free to ask any questions in here. Again, just to reiterate that if there's anything you want to know while we're going through this. So here you can see just a little more detail. The pickup replacement is over there on the left. This would actually be rotated 90 degrees clockwise, which would be A at the 12 o'clock position. And then if you're familiar with the SCRs that we traditionally had and still have with the Legacy 5, that is replaced with that surface mount switch there. So if I could just pause there for a second, if you can imagine now that before, when you had a coil of wire with a bobbin pickup coil, it's similar to a magnetic pickup. It induces a voltage. So anyone who kind of went through some of our other classes with Mike Porter and myself, we talked a lot about triggering. We talked a lot about discs and Hall effect versus magnetic pickup. So what these are, where it says pickup replacement, it's actually a Hall effect pickup. So when you've dealt with mag pickup versus Hall effect pickup, you can imagine that these are like a switch, and our pickup coils were just like a magnetic pickup. And what that means is that now we have a very, very sharp transition, and that's the reason why we only need one line on that back cover. So where we used to have a clockwise and a counterclockwise, early on, Tom mentioned that it was kind of like edge triggered. So if you went one direction, you started the edge and you would get a sine wave, positive, and it would swing negative, and then when you go off the edge, it would kind of transition the other direction and then even out. And what that did is that meant that there's a threshold in there, and when you got to a certain threshold, it would trigger. So if you could imagine, the pickup coils were very analog. So you had this kind of sine wave, and when you got to a certain point, it would trigger. So if you were to do that going the other way, obviously that would shift you in time by that round pickup coil target. So as big as that target was, it would shift you in time clockwise or counterclockwise by that many degrees. And what this does is this, as soon as it sees this Hall effect, the switch essentially will turn on. And you'll see that there's later on some benefits to that. And we'll touch base on quite a bit of stuff about starting and energy and some other things that have kind of everything placed together with these pickups and SCR replacements. So go ahead to the next slide, Tom. Okay, so I don't really necessarily want to talk in terms of benefits, although it says that that's what this is. These are just great reference material for what it brings, and then we can talk about, what the differences are, maybe how you would look at them differently in the field, and so on. So it talks about the coming in RPM, which I've had, again, this is really great feedback from the field, and some things that I've been thinking about quite a bit. So in here, it talks about the coming in speed. And for us, you'll notice that the RPM here, it says 70 to 100 on the old design. And kind of what we were talking about there was the engine RPM. So there's always the engine RPM and then the back cover RPM for anyone. And we talked about this with the gear drives and all those things, that there's engine RPM and back cover. And for a two-stroke, it's going to be 1-to-1. And for a four-stroke, it's always going to be, half engine speed is going to be the back cover. So what came up was actually that, okay, when I put this on my test stand, I'm not seeing that the actual RPM is low or low enough to what the old 5 may or may not have been. So let's just break that down a little bit. So when you look inside, we saw that we had a capacitor, we had these pickups, we had a bunch of stuff that maybe looked different but function the same. So as it sits today, we have a higher energy magnet, so it's going to give us, our energy source, which is actually higher content. We have the same capacitor to store the energy in, and about the only difference is that the pickup coil version needs speed to generate its trigger, versus us, which we do not need the speed to generate the trigger, but we use just a small amount of energy to be able to power our pickups. So those little Hall effects that I was showing you about what trigger it. So I did quite a bit of testing on this, as well as Steve Perko and Joe Lepley. They had originally done most of all of this in-depth looking around, and I just did some verification after I took some phone calls. So as you can see, everything's pretty much the same. And when we started looking at this about, why are people saying it's different? What's the deal here? And what it turns out is we both trigger the 5 at 50 RPM. I verified this on several units, and it's on every test sheet. So what that means is 50 RPM of the back cover, right? So I used a gauge as well as a electronic tack. And at 50 RPM, we can both trigger all of the coils between the Legacy 5 and the new 5. And it was a 6-cylinder unit, and I was able to fire all the sparks, and the gap was 290 thousandths to 300 thousandths. And what we started kind of replaying about how Joe had laid a lot of this out was his vision was that, and it holds true, and I'll explain why, is that you should be able to start the engine better. Now, the test stand may or may not demonstrate what you think is possible in the engine, but if we go back to a couple classes ago, especially I had done one probably 2 months ago now about some pretty in-depth ignition troubleshooting, as well as overview, and we talked about energy, and there's two things that should start the engine better in this case. So the first one is that we can trigger sooner because the Hall effect switch only needs 5 volts of voltage to be able to turn on, where the pickup coils actually require quite a bit of rotational force to trigger. So if you were to turn the spark gaps down at a certain gap, say 5 millimeters, 4 millimeters, somewhere in there, you would actually see that the Legacy 5 would stop triggering because its tank can't actually turn on, to where our turn on will actually turn on. So the fact that we could have 25 volts coming out of the alternator and our trigger circuit will actually turn the ignition on. So there's always, just talking about turning it on, there's always the Hall effect or distributor portion, and then there's always the output, which is the voltage portion. And in our case, the Legacy 5 may or may not have the voltage portion, but it loses the trigger portion sooner. So as you go down in RPM, it will lose its trigger option sooner than the newer 5, okay? The other thing is that we have a recirculation diode in the new 5, the 5NG. And what that does is, if you're familiar with the 95s and all the newer ignitions, there's a diode across the coil that gives you longer duration, and we'll see that in a slide below. We'll talk about that a little bit, but when we're firing the 5NG, regardless of whether the Legacy one or this one's firing, you will in turn get a longer duration and better, energy, duration spark. So there's more content there to light the fuel off. So in terms of the spark gap as well, the reason why that works on a starting engine, especially Stoic, if you remember what Mike Porter talked about last time, he said air is an insulator and fuel is the conductor to some degree. So what you'll notice is that with lean burns, it's a little tougher, but in general, starting an engine, you're going to be roughly at the 6 to 8 kV line, I would say. Some of the leaner ones maybe around 10, somewhere in there. But we've talked a lot about putting 7 millimeter gaps. The talk now is maybe using a 5 millimeter gap for your test stand. But I guess the overarching thing here is that on your test stand with a 7 millimeter gap that's sparking 12 kV, maybe 15 kV, you won't necessarily see the coming in speed of a engine, because at that kV, that's already past what a starting Stoic engine would have in terms of kV demand. So hopefully that clears some of that up. Like I said, I've had a couple questions on that. We'll probably be changing the literature, and I'll try to describe that better, maybe with some visuals. And I know, I've heard from some people, we've been doing the same thing for, 20 years or longer to test the 5s and the 3s. And I just want to help maybe clear that up a little bit, and wanted to spend a little more time there. I know we're running down to about 13 minutes, but I know that was a pretty hot topic. So hopefully that made sense. And if you have any direct questions on that, please feel free to get a hold of me or someone here from Altronic, and then we'll try to walk through that a little better if my explanation didn't hopefully clear all that up for you. So go ahead to the next slide, Tom. Okay. So on this type of ignition, again, you're kind of able to, in terms of troubleshooting, if there was something stuck on, that was called SCR latch-up. So there was limitations in terms of energy that we could use. Okay, so one of the things I want to talk about, and again, I'll try to move fairly quickly here, and we'll get to the duration slide in a little bit, is that with the newer technology, I showed you the IGBT, we've actually upped the voltage. So when you move to the NG, and for troubleshooting, you're going to want to, when you look at that G lead, that's going to tell you a lot about the ignition. So on this ignition, we're running in the range of 150 to 200 volts, which, if you remember back to my other talk there, that was, again, energy, because it's 1/2 CV squared. So the voltage squared for a fixed amount of block capacitance is going to up our energy. So that's going to put more energy through the gap, and that's generally at running speed. So once you get up to your running RPM, that's where we'll really kick in above a normal 5 ignition. Below that, they'll be about the same. So, say 50 RPM, we're about 55 volts, and then, kind of increases from there. So, but yeah, as you get up to the real higher speeds, you'll start to see a nice increase in the amount of energy, and then you kick that diode in and you get some duration, and it's really going to give you some performance gains there at full speed. So next slide, Tom, please. Okay, so here's the, back to what Paul was talking about earlier. You'll notice right here it says 10 kV, right? So that's important because we're trying to hold to some standard. So if you notice in the literature, they were at 10 kV originally. So we did that as well. And you'll see here that these are 425 microseconds versus 230 or so for standard 5. And again, this is a good troubleshooting, if you can look at this with a scope, if it's possible to actually see the duration, you can tell quite a bit about this. So if you're not getting the duration, it's possible that we're not getting the voltage. So again, you're going to want to maybe check your G lead. It's possible there was a damaged component, maybe a diode. So you'll notice that on the left there, the flyback is much more advanced. So about the 1, 2, 3, almost the 5th block, you see a nice large sine wave going in the opposite direction. That's almost double what the one is on the right at 1, 2, 3, 4, like the 7th block on the right. And what that's showing you is that the original Altronic 5 never had that recirculation diode. So it's putting quite a large flyback on all the components. And they put a lot of technology in back then to make sure that those components would live. So today, with newer technology, we're able to capitalize on that, give you longer duration, less stress on the components, and you'll see that ring out is less severe. So again, if you look at the ring outs, if you have a scope or you're able to use a scope, you can tell quite a bit about what the what's going on in terms of the secondary versus the primary, and really just a good indicator there. But the key thing here is, if you're looking at an old 5 and you're always used to this picture, and all of a sudden it's changed, on an NG, it's going to look, quite a bit longer. It's going to give you quite a bit more energy, and it's going to be a little bit softer. But you kind of want to look at these different parameters about the spark breakdown that's there on the left. We had talked about that quite a bit in some previous courses, and then the ring out on the right. And if you see some weird things in the middle, the one on the left there, you kind of see some chatter in block number 2. If you start seeing lots of chatter, those could either indicate, and again, this is on the secondary of the coil, so it's a high voltage probe. There's some people who have those out there. They've got the clamp-ons, some different tools there. But if you notice a lot of chatter, that could be either A, what Tom was talking about earlier, that the secondary wire is actually getting some carbon traces and burning through, could be going open, or the other big indicator there is corona discharge and your plugs are starting to wear. So just be wary of that. It's just a good little technique there that while we're looking at this, the differences between the NG and the original. So next slide, please. Okay, so one major thing about this that we've been able to kind of dial in, and we've actually made a new improvement. So we had some feedback again from the field, which is really, really good. I appreciate that. So what we found out was we can dial these in, and for you guys out there, we looked at maybe making a tool, doing a couple different things here. And if you look at the old design, how I talked about that sweeping RPM, the analog versus the digital, that digital is going to give us an exact timing every time, and it doesn't matter whether you're accelerating or decelerating. You should get less timing scatter on these because it's not analog anymore. So it's going to happen. Again, the gear mesh, all the things that Tom talked about, but this shouldn't be one of them. Okay, so you should get repeatability, quite high repeatability on these. And one thing that we noticed was, okay, so we put quite a bit of clearance, say 40 thousandths around where the back cover bearing is. and the circuit board goes around. It's got the 3 mounting screws, those types of things. We noticed that you could rotate that quite a bit, and it would actually have, because you could imagine you're not rotating it in the center, you're rotating it at the top third, that you could actually get some cylinders that were about 1 degree off and some cylinders that were maybe 3 degrees off, and you had these weird timing effects. And some of them were, absolutely perfect. And what we found out was, okay, unless you have a nice jig on this, then it's pretty hard to line up. So we went back, and the next ones that are coming out are actually like really, really close precision. So you can't really move the board that much. So that timing should go away. But we looked at making a tool. We came up with a lot of different ways to do things. But in the end, if you line that up, as best as you can, such that the board isn't canted left or right from center, then you're going to get really, really, really good timing accuracy. Not necessarily repeatability, because that's going to be the same no matter what, but you'll get really good accuracy that A to D or A to any of them is going to be much, much, much better than the legacy. So there was a few questions on that, like why is it not the same? Why is it not better? Those types of things. But all of our testing was we always just lined it up perfect and said, yeah, it's great. And then when we found out that maybe if you turn that a little bit, it wasn't so great. So like I said, we are definitely addressing that. But in terms of what you have today, if you just spend a little extra, say 20 to 30 seconds, make sure that's lined up real nice, you'll get super accurate timing, as to what we would expect, and there should be no variances. So next slide, please. And I know we have, 4 minutes. Hopefully we didn't need to take questions, because you could have asked in the middle. Again, you can always get a hold of us at any point in time. If there's any specific questions. I'm almost done here. So this was just talking about the pickup coils and the integration, the simplicity for building in the field. Instead of having to have all the combinations of the pickup plates to include the 3 pickup plates were just a nightmare. So we've handled all that in the PCBs. Super simple to service, easy to understand how it operates without all those different things. So next slide, please. Okay, good thing. Look at that, right on time. Was there anything else about the 5 and the 3? I don't know that there's anything else specific, but these last couple minutes, does anyone have any good questions they want to ask? Anything that didn't make sense on what I was talking about? Okay.
Folks, any questions for Matt or for Tom Smith or Paul, or Mike Porter, any of our other folks that are on the call?
Just a comment that the presentation was very, very useful and clear. Thank you so much for the approach. Just maybe a silly question is if you can share this presentation exactly like that to all of us, please.
Sure, we can. We will be making this video available online, but I'm sure we could distribute the presentation as well.
Thank you.
Yep.
I believe the intent is so that we can translate it to Spanish.
No, understood. No problem.
I think John has to impersonate all of us in Spanish.
Right.
He'll just record it again.
Good luck with that. Yeah. No problem, guys.